Welcome to the 12C Rack on Linux installation cookbook video part 2, where we will be performing the grid infrastructure installation. Okay, so we have opened a VNC session to node 1 of our cluster as the grid infrastructure software owner. Navigate to the staging directory, which is the directory in which we downloaded and extracted the grid infrastructure software. And prior to launching the OUI, we want to ensure that our environment has no Oracle-related parameters set. So that's Oracle Home, TNSAdmin, Oracle Base, anything that is related to Oracle should be unset. So we'll do an env here. And we can see that we do not have anything set that's related to Oracle. So we're going to go ahead and launch the OUI with the run installer command. So the first screen that you will see from the OUI is the software download screen, which provides you the ability to download and install software updates as part of the grid infrastructure installation procedure. In order to use this functionality, you would click the Use My Oracle Support Credentials for Download, enter in your MOS username and password, and if there are any patches or updates that can be installed as part of the installation itself available out on My Oracle Support, it will actually list those on the screen. You could also use a pre-download option. To use the pre-downloaded software updates functionality, you can find instructions in My Oracle Support Note 1289738.1. So this would be used in environments where your cluster nodes do not have direct access to My Oracle Support. And finally, the skip software updates is the option that we are going to choose for this installation. On the next screen, we have 4 installation options. The option that we want to choose is Install and Configure Grid Infrastructure for a Cluster. We'll go ahead and click Next. For the cluster type screen, we have 2 types of clusters available for installation. We can install and configure a standard cluster, or we can install and configure a flex cluster. The flex cluster option is new in 12C R1, and basically there are 2 types of nodes in a flex cluster. There are hub nodes and leaf nodes. So the hub nodes are tightly connected, and they do have direct access to storage. And the leaf nodes are loosely connected. They rely upon the hub nodes, and they do not have direct access to shared storage. There is more information on Oracle Flex clusters in the Oracle Online documentation. For this installation, we are going to choose to configure a standard cluster, which is very much similar to what we had in 11.2. For the installation type, we have 2 options. We can perform a typical installation, or we can do an advanced installation. We are going to choose advanced installation here just so that we can walk you through each and every one of those OUI screens. The language selection screen, we want to choose our appropriate language, which is English, and continue. And our naming, our cluster naming and scan configuration screen here, we want to enter our appropriate cluster name. It should be unique within the environment. So ours is CE Train Clue 11. Our scan name is CE Train Scan 11.us.oracle.com. Our scan port is 1521. For this installation, we are not going to be using GNS. So we'll go ahead and we'll uncheck the Configure GNS checkbox. That means we are statically assigning IPs to our cluster node members. Okay, so on the cluster node information screen, we want to validate. It's always going to detect the first node in your cluster. If you have vendor clusterware installed, it should list all of the nodes in the cluster, but As you probably know, vendor clusterware is not our best practice. We recommend installing the full Oracle stack. So we will need to make a modification here to our Node 1 VIP name. And we'll go ahead and we'll enter our remaining cluster nodes into this list. You can use the long name or the short name in here. As long as the short name is resolvable, that's acceptable as well. Okay, so at this point, we'll want to click the SSH connectivity button and ensure that SSH connectivity is functional. So we're going to go ahead and click the test button. And we can see that SSH connectivity was already established for our cluster. If you needed to configure SSH, you could do so here, but we did that in the prereq. So on the specified network interface usage screen, we can see that we have each of our network interfaces on the system defined here in the list, and the subnet in which that interface resides on. So for our implementation, ETH0 is the public network. ETH1 and ETH2 are going to be configured with HAIP. And you'll notice that both ETH1 and ETH2 are on separate subnets from one another. This is a requirement for HAIP, so ETH1 is on subnet 192.168.28.0. ETH2 is on 192.168.99.0. Again, that is a requirement for HAIP to ensure proper failover. And if you notice here, we have ASM and private listed for the use for ETH1, and we're going to choose the same for ETH2 here. So with 12CR1, there is a new feature called Flex ASM, which also allows for you to configure a ASM-specific interconnect. So this is an interconnect specific for ASM. And this is in addition to the typical private interface that you would have had in prior releases. So we are going to share that the ETH1 and ETH2 interfaces for ASM and private network communication. On this next screen, you're presented with the Grid Infrastructure Management Repository option. We talked briefly about this in part 1 of this video series. So basically, with 12C, the disk group created with Grid Infrastructure will also be used to house the management database if you choose to install the management database. It is an optional component. We do highly encourage it for the fact that without the management database, you lose Cluster Health Monitor. And Cluster Health Monitor is a valuable tool in terms of diagnosing performance-related issues at the OS level, as well as instance and node types of evictions. So we encourage you to install a management DB so that you can have full functionality of Cluster Health Monitor. So we are going to choose yes here and click next. And at this point, we are presented with our storage options. So we have the option to use standard ASM for storage, which is very much similar to, if not identical to, the functionality that we had in 11G R2. Or we can use Oracle Flex ASM for storage. And the last option, which is not best practice, is to use a shared file system. So ASM is our best practice recommendation. So we encourage you to use ASM. For this installation, we are going to choose use Oracle Flex ASM, which is going to allow for a reduced number of ASM instances to be running on the cluster, 3 to be exact, and allows for an ASM failure to not impact the database instances. So database instances do not access their storage through ASM. They actually directly access the storage. ASM simply manages that storage. So with Flex ASM, if an ASM instance were to crash, an ASM instance on a surviving node will be started, and there will be no service interruption to the database instances that were running on the node in which the ASM instance crashed. So historically, if an ASM instance crashed on a cluster node, all of the database instances on that cluster node would also crash with ASM. So this eliminates that problem. So we'll go ahead and click Next. So at this point, we're going to go ahead and specify our disk group name that will be used to house our OCR, voting disk, and grid infrastructure management database. We're going to name it OCR Vote. And we want to choose our disks for that disk group. And we want, for our configuration, we're going to choose normal redundancy, having 3 fail groups. So we're choosing 3 disks. Each disk will be in its own fail group. This will allow for 3 voting disks to be created. If you chose external redundancy, you will end up with a single voting disk. If you choose high redundancy and you have 5 disks with adequate size, you'll end up with 5 voting disks. So you'll have to have 5 fail groups for high redundancy. So though we are choosing normal redundancy and for our OCR and voting disk, and again this allows us to have 3 voting disks, we will be choosing external redundancy when we create our database data disk groups. Our database data disk groups do reside on a high-end SAN, which is using hardware RAID, which will give us the performance and the high availability of the data that we're looking for. So we don't actually need the ASM redundancy in that configuration. For the ASM password, we're going to use the same password for all accounts. It's up to you on which configuration you would like to choose here. You can specify a separate sys and ASM SNMP password if you like. On the failure isolation support screen, we are basically being asked if we want to use IPMI to integrate with the Oracle Clusterware. What this will allow for, if your platform supports it, is for grid infrastructure to actually reboot a given node via IPMI. This can prevent situations where a given system is hung to the point where it's not responding to the OS level commands that we normally use to reboot a problematic cluster node. Our configuration does not support IPMI, so we are going to choose to not use IPMI for this installation. For our OS groups, our Oracle ASM Administrator group is ASM Admin. Our OS DBA group for ASM is ASM DBA, and our OS Operator group is ASM Opper. Let's now go ahead and specify the installation locations. Our software location, so the grid infrastructure home, is actually going to be at UO1 app 12.1.0.1/grid. So we'll go ahead and click Next here. Do note that the Oracle base for grid infrastructure should be outside of the directory path for grid infrastructure. Otherwise the OUI will post a warning there. The problem that you would have in that type of scenario is you would have permission problems because root.sh actually changes from the root level all the way up to root o install. So the permissions are changed to root o install. Our inventory location is one directory above the Oracle base for grid infrastructure. So that's UO1 app or inventory, which is correct on this screen. And our inventory group name, again, is oinstall, you can see here. And on the next screen, this is a new feature within 12c. We can actually allow for the root.sh scripts to be run from the OUI, or we can manually choose to run them when prompted, as you did in previous releases. We are going to take advantage of this new feature. You can run them through sudo. I would advise that you run them as the real root user credentials, if possible. If not, you can, again, resort back to the previous functionality where you get a prompt to run root.sh manually. We are going to use the real root user credentials, and we're going to go ahead and enter our password here, and we'll click Next. So again, the root.sh scripts will automatically be run for us as part of the installation. Go ahead and allow the clue verify checks to complete. And you can see that we have one warning here, which is device checks for ASM. Let's go look at the details, and we can see that we have unique IDs failing across the cluster nodes. So basically what this is saying is it couldn't determine that the disks that we're using for OCR and voting disk are actually the same physical disks across each of the cluster nodes. This is actually a problem that's specific to Oracle VM systems, which is what we're installing upon. So we can go ahead and ignore this issue. But if this were any other system, I would suggest that you go back and you validate that the disks are truly shared manually. So we'll go ahead and we're going to click the Ignore All button, and we'll click Next to continue. We'll get a prompt saying that we skip prerequisite checks. Are we really sure we want to do that? In this case, yes. We'll get an installation summary screen, take a review of that screen, and we'll go ahead and click Install to begin the installation. Our software has been copied and propagated to all nodes. Right now we're updating the inventory, and then once this is complete, the automatic execution of the root.sh scripts will be performed. So we're getting a prompt that says configuration scripts generated by the installer need to be run as the privileged user, which is root. We did enter those credentials earlier, so it's asking us if we want to go ahead and execute those scripts as the root user using the credentials that we provided within the OUI earlier. So we're going to click Yes. It goes ahead and it executes the root.sh scripts for us. So no need to log into another terminal session any longer, as you had to on previous releases. The time that it takes to actually execute these root.sh scripts is highly dependent on the system itself that these scripts are running on, so be patient. This video does not accurately depict exactly how long it's going to take for those scripts to actually run, so be aware of that. Alright, so now that we're 100% complete and we can see our installation of Grid Infrastructure was successful, go ahead and click Close. That's it for the Grid Infrastructure installation. Let's go ahead and move on to the install of the database software.